Okay, we've got this WP rather, and then T and then U. It's a cyclic quadrilateral. We've got UW equaling UT. Well, we know what makes those angles equal. That's a good thing to know. We got chords intersecting at Q here. And we've got that SU is parallel to WT, and we need that. I'm sure we need that to make everything else work. So let's just, how are we going to get started? Proving that US is tangent to the circle PWUT through all these points. So it's a tangent to the circle going through right there. Okay, well, let me think here now. What are we going to do? We know that U1, we're going to prove that. We know that this U1 here is equal to W2 because of alternate angles. Well, that's a pretty good thing. We also know that this angle here, T1, has to equal W2 because of angles opposite equal sides. Well, that means that this must be a tangent to the circle going through these 3 points here because of the converse of the tan chord theorem. The angle between the tangent and this chord here equals the angle in the alternate segment. And wow, we've got P2 is equal to X because of angles in the same segment, because it's a cyclic quad. We've got the converse of the tan chord theorem happening here. And now that's how I wrote it all out. U1 equals W2 because of alternate angles. W2 equals WT1, angles opposite equal sides. Therefore, those two guys are equal, U1 and T1. SU is tangent to the circle going through U, W, and T. But T1 is equal to P2, which is angles in the same segment. So it means that SU is tangent to the circle going through U, W, and P. I kind of feel if it's part of a cyclic quad, it would kind of force it to be a certain, anyways, but this seems to prove it. Okay. Now, prove that triangle SPU is similar to triangle SUW. Well, go for SUP, make a nice little red lines around so you can see it. Well, they've got this angle S in common, and SUW is this little one right here. They've got S in common, and U1 and P2 are the same. Well, if they share two angles, then the third angle must be because of angles in the sum of a triangle. So that's all we have to write down. SUW equals WPU. We proved it already that they're equal. S is common, therefore these two triangles, SPU and SUW, must be similar. Angle, angle, angle. And my math type gave me an extra line there. I don't want that line there, but there it is. Okay, so there's that one done. Question 10.